So let's look at stratified sampling, which is a third form of probability sampling. This basically is what you would use when you're going to put people into groups first, and then you take the sample. This is supposed to increase how representative a sample is, and so it's supposed to make sure you include people from specific groups. So let's look at the reality that a lot of times in research, people of color are underrepresented relative to how much there are in the population. So if you start with a list of clients and you divide them up by race, and then you take a sample within each group, let's say you select 30 clients who are African American, 30 who are Hispanic, and 30 white, then this is stratified sampling. What you see here is then you get a pretty good comparison where you've got a really diverse sample, versus if you had just randomly selected from the list of clients, you could have ended up with 5 people who are African American, 3 who are Hispanic, and 90-something who are white. So this is a way of ensuring that you've got small groups that are well represented. If you're spread out, it's a way of making sure that you can reach those groups. You may have different sampling problems, so what we've talked about, issues with, say, who's on a phone list, who has a cell phone, who is listed under an address or not. Those types of issues will still come up, so it is more complicated because you may have a greater variety of sampling problems, but the whole idea is that as long as these groups are pretty similar, you will be able to reduce that sampling error of potentially underrepresenting certain groups, and you can now be more comfortable that the results are going to more easily translate to all African Americans and all Hispanics and all whites in the population. The fourth technique, or the fourth type of probability sampling is called cluster sampling. And so this is when, let's say you just don't have a list. Maybe you're trying to reach a population of sex workers. There's no list and there's no possible way of getting a list of everybody who's in that group. So maybe you start with a small sample. You start with sex workers that might work in a certain police as a district. And so let's say that you work with police officers and you ask them to identify all the different street corners where street level sex workers are more likely to be found, and you send several different people in your research team to sample all of these different sites. So if you start off, then that's how you develop your list. And then from that list, each of you will have a cluster. So maybe different teams went to different street corners. And then from there, you'll draw a random sample from each corner. So you kind of get naturally occurring groups, clusters, and that's how you end up with your list of clients. So again, the idea here is that it's probability relative to the size of how big you can get within that cluster. It is important to think about, if you've got one area where there are 30 people and another area where there are 20 people and there's different probabilities, then you may have to use some statistics to basically adjust for that. But overall, this is a good technique when you just don't have an easily available list. So just to review, probability sampling can be very simple, can be very difficult, very time consuming, very expensive when you think about all the lists that you have to generate, who to include, but it is the most effective from a scientific perspective because that random element, the fact that everybody has an equal chance of being selected, avoids those biases that you might have in intentionally picking people. So if everybody has an equal chance, there's no bias and you minimize that sampling error.